This is section 6.1, scientific notation. Our objective today is to write numbers in both standard form and scientific notation. Let's look at our vocab word. Scientific notation is used to write really large numbers or really small numbers, and it's done by using powers of 10. So an example of scientific notation is 3.4 times 10 to the 7th power. If the 10 has a positive exponent, it's a really big number. To find the standard form, we'll move the decimal to the right that many places. For negative exponents on the 10, that's used for really small numbers. To find standard form, which is normal form, we move the decimal to the left that many places. So why do we care about scientific notation? Well, it's very helpful when we're dealing with really big or really small numbers. For example, the volume of the Earth is about 259 billion cubic miles. Instead of writing all those zeros, we can just say that that number is 2.59 times 10 to the 11th power. My question for you, what is standard form? Well, it's like the normal form, like the 259 billion. So to change scientific notation to standard notation, we move the decimal point to the right for positive exponents of 10. The exponent tells you how many places to move. We move the decimal point to the left for negative exponents of 10. Again, the exponent tells you how many places to move. And then we write the resulting number. So the temperature at the sun's core is about 1.55 times 10 to the 7th power degrees Celsius. We're going to write that temperature in standard form. So let's start off with the number, 1.55. It's a positive power of 10. So that is number 1 here. We move it to the right. So 1, 2, 3, 4, 5, 6, 7. Put zeros in anywhere we don't have a number. So we have 1, 5, 5, 0, 0, 0, 0, 0. Put in some commas. We have about 15,500,000 degrees Celsius. All right, we're going to try writing these in standard form. To write 3.2 times 10 to the 7th, we take our decimal and we move it 7 places. 1, 2, 3, 4, 5, 6, 7. That is 1, 2, 3, 4, 5, 6 zeros. So 3, 2, 1, 2, 3, 4, 5, 6. Put in my commas, 32 million. Now 2.3 times 10 to the negative 5th. A negative exponent, I move to the left. So 2.3, 1, 2, 3, 4, 5. And that's where the decimal goes now. So 0, 0, 0, 0. It looks nicer if we put a 0 in the front. And we have 1, 2, 3, 4 zeros, 2, 3. There's our new number. Try this one. Write 1.77 times 10 to the 6th kilometers squared in standard form. This number is the area of Australia. All right, to do this, we take our 1.77, we move it 6 places. 3, 4, 5, 6. That is 4 zeros. 177, 1, 2, 3, 4. Put in my commas, and there we have it. We should label it, because since we have a label, kilometers squared. To change standard notation to scientific notation, we place the decimal point so that there is 1 non-zero digit to the left of the decimal point. We count the number of decimal places the decimal would have moved from the original number, and this will be the exponent of 10. And then a very large number will have a positive exponent, and a very small number will have a negative exponent. So a supercomputer can perform a whole bunch of operations per second. We're going to write this number in scientific notation. So the first thing, we place the decimal points. There's 1 non-zero digit. Well, that would be between the 1 and the 3. So 1.353. It'll be times 10 to a power. Now we have to count. Well, if it was right there, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. It's a really big number, so it is a positive 14th power. We're going to write these in scientific notation. For the first one, we write 4.1. We would move it once, twice, 3, 4 times. So times 10 to the positive 4. The second one, we're going to write 4.17 times 10 1, 2, 3, 4, 5 places, but that's a -5 since it's a small number. Try this one. Write this number, the moon's diameter, in scientific notation. All right, you should have written 3.476 times 10 to the 1, 2, 3, 4, 5, 6 power. Fingernails grow about 1.23 times 10 to the -2 centimeters per day. Write this rate in standard form. Try this. All right, we should have moved the decimal once, twice. So 0.0123 centimeters per day. Write 2.5 times 10 to the -4th inch, the diameter of a cell, in standard notation. Try this one. All right, we're going to move our decimal place 1, 2, 3, 4 times. So 0.1235 of an inch. Write this quantity in scientific notation. Try it. All right, we'll have 7.6 times 10. 1, 2, 3, 4, 5, 6 places. So -6 power. And one last one. Write this in scientific notation. All right, we'll start with 3.5 times 10. Move it 1, 2, 3, 4, 5, 6 places. So -6. Here's your assignment.